Welcome to the deep dive. Today, we're going to cut right to the chase on a really powerful piece of hardware.
The Thor Broadcast F-1MSDI TX RX kit.
Exactly. So if you're prepping for a meeting or you're just curious about how you solve these big, long-distance broadcast challenges, this is your shortcut.
And it really is a logistics game changer. I mean, the core problem it solves is that spaghetti monster dilemma.
Right, all the cables.
Yeah. How do you send 8, high-definition broadcast quality video streams over huge distances?
And without any signal loss.
Exactly. Without running a truckload of copper.
And the answer, inside this kit, which for context runs about $5,495, is a single strand of fiber.
That price tag tells you it's mission-critical stuff.
It does. And for anyone listening, when we say HD-SDI, we're talking about the uncompressed video quality that professionals absolutely demand.
Right. And its main capability is, it's stunning. It transports 8 of those full-rate HD-SDI signals.
And each one is running at 1.5 dBps.
Each one. That's a staggering amount of data. Think about it. It's like moving thousands and thousands of high-res photos every single second, 8 times over.
Okay, so that's the bandwidth. Let's talk about the distance. We're not just sending this across the studio floor.
Oh, no, not at all. We're talking regional. The standard distance is 20 kilometers.
Oh, 20 kilometers.
But the kit can reliably go up to 80 kilometers. There are even options for 100.
And you can't do that with a normal coax cable. You'd lose the signal after, 100 meters?
You wouldn't even get that far, not cleanly. So the distance alone is transformative.
So my question is, how on earth do you send 8 super high-speed sensitive signals down one tiny fiber for dozens of miles without them all, corrupting each other?
And that is the aha moment. This is where it gets really clever. They use a technique called CWDM.
CWDM.
Coarse wavelength division multiplexing. The key is it uses a different color of light, a different wavelength for each of the 8 signals.
So they're sharing the same physical path, the same glass, but they're completely isolated from each other because they're different colors.
Precisely. They're totally unaware the others exist. And that isolation is just non-negotiable for live broadcast. It keeps the timing and sync absolutely perfect.
No video tearing and no audio drift?
None. And just for compatibility, the inputs handle everything from the older SD-SDI all the way up to that full-rate HD-SDI.
That makes a lot of sense. So once you've laid that fiber for the really high-value video, you'd want to cram as much other utility onto it as possible, right? What else can it carry?
That's where the dual ports come in. You get 2 independent, customizable auxiliary links.
And what kind of customizations are we talking about in, real-world field setup?
Well, you can mix and match. You might need, say, up to 4 analog audio channels, bidirectional.
For talent talkback or cue lines?
Exactly. Or you could dedicate a link to RS-232 or 422 data for controlling complex equipment.
What about the really simple stuff, like just knowing if a switch is on or off 100 kilometers away?
That's handled by contact closure lines. You can get up to 4 of them per interface. It's simple on-off signaling.
Like for a tally light on a camera.
Perfect example.
Yeah.
Triggering that little red light. And on top of that, you get a dedicated RS-485 channel coming back, specifically for controlling things like remote pan-tilt cameras at the far end.
So really, this kit just solves a logistical nightmare. The whole point is extreme efficiency.
It is. You take 8 high-quality video streams, your utility audio, all your critical control data.
And you put it on one single physical path that could stretch across 80 kilometers.
It just massively simplifies everything, reduces your points of failure. Which brings up a really interesting thought for you, the listener.
Go on.
Okay, so we see how CWDM solves this massive distance and bandwidth problem for broadcasting. But think about other fields. What about real-time remote operations?
You mean like medical robotics or heavy drone operation?
Or even remote surgery. What other fields do you think are on the verge of needing this exact same kind of dedicated multiplexed fiber capacity to bridge these huge physical gaps? That's where the potential here really explodes.